You ever stop and think about how the internet actually works? Like how it handles millions of us all at the same time without just falling over? Well, a huge piece of that puzzle is thanks to a quiet workhorse piece of tech. Today, we're going to pull back the curtain on a true original, the classic load balancer. All right, so to really wrap your head around the classic load balancer, or CLB for short, the best way to think of it is as the internet's very first traffic cop. Now, it wasn't the smartest cop on the beat, it couldn't do fancy routing to specific spots. But it was the first one on the scene, and it did the one job that mattered most. It kept the traffic flowing and prevented total gridlock. So let's rewind a bit. This thing launched way back in 2009, and for years it was the standard, the go-to solution. But by the middle of the 2010s, the internet was just exploding with new ways of building things, like microservices and containers, and the CLB, well, it started to show its age. Today, it's what we call a legacy service, and its journey is kind of like a perfect mirror for just how fast the web has changed. So, before we get into why it was eventually left behind, let's just take a minute to appreciate what made this thing so revolutionary in the first place. What exactly made this original traffic cop so darn good at its job? Here's what was so killer about the CLB. It could basically do two jobs at once. See, it could work on two different network levels. At layer 4, the transport level, it was just managing basic connections. Think of it like a traffic light, just a simple go or no go. But it could also work at layer 7, the application level. And that meant it could actually look inside the traffic, understand the HTTP requests, and make much smarter decisions. For its time, having that dual ability was an absolute game changer. And it came loaded with features that were seriously powerful back then. SSL offloading, that meant the CLB did all the heavy computational work of encrypting and decrypting traffic, which freed up your actual web servers to, serve the website. Health checks were like a constant patrol, making sure that it only sent traffic to servers that were actually healthy and online. Sticky sessions made sure that you, as a user, stayed connected to the same server, super important for things like keeping items in an online shopping cart. And connection draining was this greaseful way of letting users finish what they were doing before a server was taken offline for an update. It was a true, reliable workhorse. But you know how it is in tech. Things move at lightning speed. The web kept evolving, the way we built applications changed, and pretty soon our basic cop started to get a little overwhelmed. So where did the cracks start to show? So for all the things it did right, where did it fall short? What were the things it just couldn't do? The answer to that question is really what paved the way for the much more specialized tools we use today. Okay, this right here, this was the biggest limitation. It couldn't do any kind of advanced routing. The CLB could only take all the incoming traffic and send it to one big group of servers. It couldn't look at a URL and say, oh, this is an API request, send it to the API servers, or that's an image request, send it to the image servers. Our traffic cop could only direct all the cars to one giant parking lot. It couldn't tell them to go to specific reserved sections inside. And that problem got even worse because of its one instance, one port design. Now, that was totally fine for the big single application websites of the past, but for the new world of microservices, it was a deal breaker. Suddenly, developers wanted to run lots of tiny, independent services on a single machine, each listening on a different port. The CLB just wasn't built for that world. And that brings us to the final nails in the coffin, really. It had zero native support for container technologies like Docker, which were taking over the world. It was built for virtual servers, not for these new lightweight containers. And when you put it all together, for the kind of complex, bursty traffic we see on the modern web, it just wasn't the most efficient or cost-effective option anymore. So, does that mean it's gone for good? Well, not quite. The classic load balancer is still around, quietly doing one very specific and very important job in its retirement. I mean it. Just one. In this entire vast landscape of modern cloud computing, there is really only one major reason left to ever deploy a classic load balancer today. And that one reason is something called EC2 Classic. This was the original network layout in AWS, a single, flat network where everything could talk to everything else. This was long before the secure, isolated virtual private clouds, or VPCs, that we all use as standard today. And if you happen to have a really old application still running on that legacy network, the classic load balancer is the only one that can talk to it. It's the only traffic cop that still knows the layout of the old city. So even though it's been retired from most of its daily duties, you just can't deny the CLB's legacy. It really did lay the essential groundwork for the scalable, resilient internet that we all completely depend on now. Think about it. By being the first to solve that huge problem of how to reliably distribute traffic, the CLB made it possible for an entire generation of websites and applications to grow up in the cloud. It was the crucial first step that made so much of our modern internet even possible. And you can literally see its DNA in everything that came after. The CLB's limitations directly led to its successors. The need for that advanced path-based routing and container support, boom, that gave us the application load balancer, the ALB. The need for just raw, super high-performance networking, that's why we have the network load balancer, the NLB. Each one is a direct answer to a lesson we learned from the original pioneer. So, as we wrap this up, here's something to chew on. The classic load balancer was once absolutely essential tech, and then the world moved on. What piece of fundamental technology that we all rely on every single day is going to be the classic of tomorrow? I'd love to know what you think.